So, thank you. I realize that we have very limited time, so I will go fast.
Thank you.
My name is Bhupinder. I'm CEO, co-founder of SwissVault. So I'll skip some slides, but I want to mention the SwissVault project. The SwissVault project started right here in Basel. It was a need to manage lots of data, healthcare data, and manage it for a long period of time and manage it securely. And we never found a solution in all the times I was working in big pharma here in Basel. And so we invented a solution. So it's a solution that we figured out here in Basel. And I want to talk a little bit about it, but it actually fits very well with data sovereignty because the issues that we talked about, that's already been mentioned. So I'll skip this slide, which is just says data sovereignty is what is important, and then this slide that says that the data sovereignty is governed by laws and regulations. But we often talk about it's made for just a nation state. But where I extend the definition to is not only that, but to indigenous groups or various groups. And indigenous groups also want to collect and use their data, and we don't want to make sure that they're cut out of the ability to participate in this in the global sort of economy, just because they don't have the wherewithal to manage the data. And of course, I want to actually extend that to the individual, because individual liberty, our democracy is dependent on individual liberty. So we should be able to extend that to individuals to autonomously use and own their data. But there are technical issues. So I'll jump right into that. First is, of course, regulations. But the regulatory side, which defines the legal rights and responsibilities, is something that we've already been sort of mentioned, but I will not go through it. I'll talk a little bit only about the technical side of this problem. The way we manage data today is an expensive undertaking. To solve one problem, i.e. data sovereignty, we don't want to create another problem like electronic waste. So when we came upon this, when we started the SwissVault project, we did a lot of research about what are the problems that make it difficult to manage this data. And there include the hardware side and also the data robustness side, the data availability and accessibility. So let's jump into the problems. The first problem is that data is growing exponentially around the world because of all the digitalization that we are doing. And the red graph here shows that 300% growth in the next 4 years. So we need more and more space to store this data. And what you might not know is that data management uses 3% of the global energy consumption. That's more than what Germany consumes or Japan consumes. So it's very difficult to think about how we're going to manage this infrastructure so that that we're actually doing this in a sustainable way now that we need to make sure that the earth doesn't crumble beneath us. So I want to point out some very interesting thing. When you send a single email with one attachment, it has the same carbon footprint as a small plastic bag. We use 100,000 plastic bags around the world every second, but we send 3.5 million emails every second. So data carbon footprint is growing astronomically. So we were participating in COP26 with the express mission to show how we can decrease data's carbon footprint. And I'm going to talk a little bit about that problem. So the problem largely is due to this data storage rack system. It's used as a standard system across all data storage systems, especially data centers, main data centers. It was actually first used back in 1880s, if you can imagine this kind of architecture, to hold the Morse code equipment and Morse code electronics. And then when the telecom industry started, it was also adopted for that. And then when the data storage industry started, they adopted the same form factor. And of course, they use a lot of energy, and they require lots of cooling. So you need a lot of warehouses and massive data construction. And of course, they have a 3 to 5 year lifespan, which results in lots of electronic waste. And that results in a total cost of ownership that's very high. So at the SwissVault project, what we did is we decreased the energy, decreased the space, increased the lifespan. And I'm going to talk a little bit about that in this slide. So you can see a single rack here has 2.5, a standard rack has 2.5 petabytes PB of data storage. Our system has 10 petabytes on the right-hand side. That's 4 times more data storage, but it's only 1/3 the size of the rack. That means our data storage density is 14 times more than the standard rack. And look at the energy on the bottom, 7,200 watts per petabyte. Ours is 780 watts per petabyte. That's 1/10 of the energy consumption. So that's why our technology is enabling customers to store more data using less space and less energy. And of course, that reduces the costs. So let's look at how the problem of reducing data's carbon footprint. The more energy you put into a system, the more you need cooling and other stuff. So that's a direct correlation with the carbon footprint. Because our energy consumption is much lower, our carbon footprint is much lower as well. The typical racks need massive data center space, and this is a big problem for data sovereignty issues, because how many data centers will you make? How much infrastructure will you need? And what we did was we made something that's lightweight, low noise, small volume, low heat output. So you can repurpose existing buildings, and that decreases not only the carbon footprint, but also the cost. In fact, for most organizations, dental centers or governments, they can bring our data systems back into the office. Finally, the typical racks are made of so many parts, and that results in accumulating electronic waste because of the 3 to 5 year lifespan. What we did was we purpose-built the system for the circular economy. We got rid of most of the parts that we don't need. We designed it with pure metal sort of thing, so it's easier to recycle. And we increased the lifespan of some major units to 20 years sort of thing. So that decreases electronic waste. And we are designing for zero waste with a consortium that we built with the University of Gothenburg and also an institute in Austria that does electronic recycling. So we're trying to go for zero waste for data storage systems. So this will be a big achievement in overall. So I think in summary, to enable data sovereignty, you need to have an infrastructure, and the infrastructure is dependent on equipment that equipment has to enable you to build a sustainable infrastructure. And so that is the hardware part of the problem. So I'm going to shift now to the software part of the problem. The technical challenge I mentioned earlier is also about how to have robust data. The data that has to be always accessible, and so that you can't have over time, over 10 years, 50 years, you can't have that data not accessible or available, because that will be a limiting agent for data sovereignty, in fact. So here I show an architecture where you have 5 hospitals in any canton or region. Right? If you have a single point of failure where you store the data files, whether it's one disk or one computer, if that disk or computer fails, the data is not available. So here I show a network of 5 hospitals where a patient may be treated. Here the file is stored at one hospital in the green 3 bars I show at the bottom. If the patient shows up at the hospital, but the computer hosting the file goes down, it's no longer available. So it's practically useless. So it's not practical to store 5 copies of that file, because that means that you've increased the overhead for that data 5 times. That's more space and more energy. So this architecture for single point is highly risky for data loss and also lack of data availability. Instead, what we do at SwissVault is that we increase the reliability of data and availability. At SwissVault, our software is focused on a wide distribution of data. So in the 5 hospitals, a single file book. Yep.
I ask you, maybe we should maybe increase the speed a bit. Sorry to interrupt.
Okay. So basically, the idea here, I'm finished on 2 slides.
Okay, good. Yes, thank you.
Okay, so just say that a single point of failure here means that when the patient shows up at the other hospital, the data is still available to that individual, because certain parts are available. So this architecture reduces the overhead, because you don't need to make 5 copies, and it increases the security of the data file, because no one can steal the data without knowing how to assemble the complete file. Okay, so that's data robustness, no single point of failure, distributed data architecture, and of course, distributed computing architecture. So I'll skip the next slides, because our use case is primarily for healthcare data, but it can be used for government or banking data or any kind of data in particular. And what we aim to do is that this is the team. I want to give credit to the team that's been developing the technology. And I want to end there. Thank you very much, and I look forward to the questions afterwards.